So dear students, in this video we are going to discuss about magnetic force. So under this, firstly we will see a bit about Lorentz force. Lorentz force. So basically, what is Lorentz force is, suppose you have a charged particle. Let us take a positive charge plus q at any point in space, and if there is some electric field around certain direction on that space, if there is electric field uh, okay in space around at any certain direction, then we know this positive charge will experiences a force, that is a Coulomb force. So electric the amount of electric force experienced by the positive charge is your plus QE. So the force will be along the direction of the electric field, and it is known as Coulomb force. Now, suppose let us consider the charge is moving with certain velocity of v vector along certain direction, and at that point where the charge is moving, there will be, or there is a magnetic field which is going inside at that particular space. So at that point, charged particle is moving along, let us take this direction, and magnetic field is perpendicular to the direction of the velocity. Then we know there will be a magnetic force which is expressed by a relation Q V cross B, where V is the velocity of the charged particle and B is the amount of the, or it is the basically magnetic force. So B is your magnetic force. Magnetic force. So when we combine these two, we'll get Lorentz force F is equals to, this is known as Lorentz force, Fe plus Fb. So Fl is your, Fe is plus Qe plus Q V cross B. So this particular force is known as Lorentz force. It is a combination of the forces experienced by a charged particle in space, comprising of both electric and magnetic fields. This is your Lorentz force. So our focus is basically on magnetic force. So we got the relation for a magnetic force. So magnetic force is basically Q V cross B. So the point to be noted here is, if the charged particle have V velocity, then only there will be some magnetic force. If velocity is 0, if this V velocity is 0, then magnetic force will also be 0. That means static or stationary charges do not experiences a magnetic force. So stationary or static charges do not experience a magnetic force. That means only moving charges experiences the magnetic force. So since in this particular relation all quantities are vector quantities, force is a vector quantity, velocity is a vector quantity, and magnetic field is a vector quantity, so there is a rule to remember the direction of the respective vector quantities, and that is known as your left hand rule, or it is also known as Fleming's left hand rule. So Fleming's left hand rule is basically, if this is the direction of so I'll depict this way. If this is the velocity, this is your magnetic field, then force will come out. Then magnetic force will be outside this clear paper. That means if a charge is moving towards this y direction, so this is a charge basically. So if the charge is moving towards this y direction, then, and at that point if magnetic field is along this direction, then that charge will experience some force, that is magnetic force, which will be out of this plane of paper. So it is basically depicted by this particular rule. This is a magnetic field, this is a velocity of charges, and this is your force experiences by the charges. So hope you will remember this particular rule. So we'll meet in the next video. Thank you.